Hello, hello. Can you hear me? And can you see my screen? Okay, so let's go. Today I will introduce the talk control of our VD2 series server. And first of all, thanks for attending today's training because I know today is Friday. Maybe some people don't work tomorrow, but you still come here and to learn our products. So I hope you can understand all the contents today. Okay, first here for today, I will introduce the talk control modes of our server through these four parts. First, the introduce of control mode. Here, for control mode, for these talk control modes, it means our server will control our motor to output a constant torque to driver our driver the loads. So usually we will this torque mode were usually used in winding machine and saw machine and unwinding machine and so on. Some application which will have requirements about the torque, and usually we will use torque control. And here we have two way to set the torque of our motor. And you can see this two is similar to the speed mode. First way is use analog inputs to set the torque. And the second way is use internal torque command to set the torque. And for torque and for the relationship between torque and current, you can see the relationship is a linear relationship. It means the bigger the output current, the bigger the output torque. So in fact, we are controlling the output current to control the torque. This is a rewinding. This is a rewinding case, and when the rewinding distance reach 100 meters, the motor will stop and the cutter will move to cut the copper. So here, the paper is go this way always, and this will rotate in this direction to feed the paper. And this is an distance measure encoder. You have R to check the distance on the paper. So you can see, for example, usually here we maybe have another one. And rotate in this direction to unwind the paper. So here, why we need to use torque control? Because we can see as the systems running, the ratio of the paper will be smaller and smaller. So it will cause the line speed of the paper will be maybe always changing. So in order to keep these two parts always have same line speed or same linear speed, we have to use torque control. Because with the torque control, we can ensure the tension of the paper is always a constant value. So it will make our paper not too loose or be damaged. Because for example, because if here the speed is increased, the speed here will always increase to keep the tension of the paper be a constant value. So in this application, so in this application, we will use torque control. Internal torque source. Okay, now now here I will introduce some parameter about internal torque source. First thing we need to use this parameter P0 and 1 to set it as torque control. Okay, and the next we need to set the torque command source. Here we have two sources, which is similar to speed mode, and also for VD2F, for this series servo don't support analog input, so we can only select 0 internal torque command for VD2 series servo. And here, how to set the internal torque value? We use this parameter P1 and 8. This parameter to set. The unit is 0.1%. So it means, for example, if we set this value as 500, it means we are using 50% 50% rated torque of our motor. For example, if our motor is maybe rated torque is 10 this value, and if we set P1.8 as maybe 200, so it means 20%. So the motor will run into Nm in this torque. Okay, so P1 and 8 is used to set the torque of the motor, and this parameter U0 and 39. U0 and 39, this parameter is used to read the real-time torque of our motor, and the unit is also percent. This percent is based on rated torque of our motor. Here 10.3. So if our rated torque is 10 Nm, so this means 1.03. This means So this is how to set and read the torque of our motor. And also there are some torque limit parameter. First one is torque limit source. We can use internal instruction to set the torque limits, or we can use analog input to set the torque. And usually we use internal instruction to set the torque. So if we select internal instruction to set the torque, then we need to use these two, forward torque limit and reverse torque limit, to set the torque. And also the value is the unit is 0.1%. 100%, yes. And here, this curve have describe the relationship between our motor torque, log torque, and speed. Because you know, yes, 3000 means 300%. But usually we didn't set such a big percent, because it will make our driver reports overload error. Usually we set the torque below, within 100. Because only within 100 the motor can continue or always run. If we set this too big, maybe 200 or 300, after running a while, the driver will report an error about overload. Okay, so here we can see if f is bigger than 0, then the motor will always get one acceleration. So the speeds will always speed up and speed up. This f is the how to say the torque. The torque reduce the friction. So we can see if our torque is bigger than the log torque, the motor will always speed up. And if the motor torque is same with the log torque, so we will see A will be 0. So the motor will keep current speed and run and always running with the uniform speed. And if our torque is smaller than the log torque, the motor will speed up. Slow down until the speed is achieved 0, and then keep stop status. So this is the relationship between our motor torque and load torque. So for that case, for this case, we usually set the torque the torque of motor is same with the torque of the rod. Here rod is the paper. For example, maybe we need maybe 2 Nm this torque to make our paper how to say, to make our paper not too loose or damage it. Maybe we need this torque, so we set this torque as the motor torque. So we will get uniform speed always. Yes, you are right. To keep our paper tight. You are right. Okay. And now we can check this curve. Here, this curve. The blue one is input torque, and yellow one is real time speed and real time motor speed, and this green one is real time torque of our motor. So you can see this is the torque command we set, and from these points, the torque of motor will begin to go up, and achieve this positive torque limit and keep the torque here. This is a torque change, and for speed, first in this segment, the speed will speed up, and this segment, the speed will also speed up. You can see for these two segments, the acceleration is different because here the torque is small, so acceleration is small, and here the torque is bigger, so the acceleration is also bigger, and achieve these points, the speed will here keep uniform speed, and we can see the torque will become smaller because we don't need a big usually we don't need a big torque to overcome the friction of our rod, so the torque will be smaller here, and another direction is similar. Yes, you're right. If the motor torque is smaller than the rod torque, the motor will first to slow down. For example, the motor have already run in maybe for example 200 RPM, and then it will slow down to 0 RPM. Sorry, and then keep 0 RPM. And here, this parameter is used to set the speed limit. Speed limit in torque mode. And also we have two ways to set. First one is used in internal parameter. Use servo parameter to set the speed limit. And another way is use analog input to set the speed limit. So here, why we need to set a speed limit under the torque control? Because we need to prevent the motor. Because from here you can see if the motor torque is bigger than our torque mode, motor will always speed up and speed up. For example, we set the torque as 10. and also our load torque is also 10. Then the motor will keep its speed. It's safe. But for example, if there are something happens and our load becomes smaller, or the load becomes smaller. Yes, for example, it's changed to 8 or changed to 7. So it will cause our motor begin to speed up and never stop if there are no speed limits. So the motor will always speed up and speed up, and it will be very dangerous. So we need to set the speed limits in the torque mode. It means when the speed is achieved the speed limits, the motor will not continue to speed up to prevent some dangers happen. How we know the load torque? This variable we need to calculate, or you can use some tool to measure, to use some tool to check the torque of the loads. For example, you want to lift up this load, and it is maybe 1 kg. So you will need 9.8. This is the how to say, this is how the max of our loads. And also here you have maybe have a wheel to rotate to move this on. So the torque will based on the wax of our loads, and also based on the ratio of this wheel. So there are some calculation about to get the load of our the torque of our load. Yes, and here in fact we have I remember we have a document. Let me find. This one, I think. Oh, yes. Motor select. So you can see here we have a have another presentation and introduced some commandly used application about how to calculate the torque of our load, like this. And also I think you can also find something like this, some application how to calculate the torque on internet or somewhere. Also, if you need okay. Okay, continue. Here, we use these two parameters, P1 and 11, 1 and 17, and P1 and 18. These two parameters to set the forward speed limit and reverse speed limit. These two, and these two parameters is only work in torque mode. In speed mode, we have another two parameters to set the speed limit. And the P4 and 4, this parameter is used to set the filtering time of the torque command. With this setting, the torque will be more, how to say, more stable. But usually we don't need to set this parameter too big. It will cause the response speed. The speed will be reduced. For analog source is similar to speed source, so I think we can speed up. We can speed up for this part. Also, we need to set the analog, adjust the analog value, analog inputs by setting the zero drop and bias setting. So here, how to set the analog value relationship between analog value and torque value? We use P5 and 10, this parameter. And the range is between 0 to 3000. And the 1000 means 100%. The curve, the relationship curve is here. You can see this one this part is similar to yesterday's class about speed mode. Okay. So, and last I will introduce some commonly used DIDO, and then I will connect motor to set torque of our motor and check the torque curve and the speed curve later. Here, usually for in torque mode, we usually use this is DO, digital output, torque arrive and torque limit. These two maybe commonly used. Torque arrive means, for example, if we set the torque as 10, and when the torque is achieved 10, this DO will output one signal. And torque limit is also means when the torque is achieved the torque limit we set, it will also output one signal. Here I have these two parameter. These two parameter also will will be commonly used in torque control. P5 and 20, P5 and 21. These two parameter, how these two parameter works. For example, if we set P5 and 20 as 100 and set P5 and 21 as 10%. So every time when the torque of motor is bigger than 110%, this signal will become on status. And every time when the torque is smaller than 90%, this torque reach signal will become disabled, become off status. And when the torque is changing between 90% and 110%, this torque reach signal will not change. So why we need this one, P5 and 20? Why we need to set this one? Because the torque will not be a constant value. I mean the real-time torque. For example, we set it as 100%, and when it achieves 100%, it may be changed like this. Maybe between 95, 97 to 102 or to 103. There will be a range, always changing. So if we didn't set this 10%, what will we get? We will get this torque reach signal like this, always changing, always changing. So this is not what we want. So that's why we need to set this P5 and 21 to just like to set an area, and between this area, we think the torque didn't change. So we can get the signal, reach signal like this, normal one, just like filter, yes. Can see here, first picture, this signal will like this, and the second signal will not have this part. Okay, now we can connect our motor. Change to English. Now the motor, now the driver is in a ready status, so we first need to enable it. Here we use DI1 to enable the servo and use hardware. So here we just need to change the logic. Change the logical of DI1 channel. Now it's changed to run status, and now the motor is running. Okay, and here first torque mode, set it as 3, and now it is 3 already. And the second control parameter. Here torque command source. Here we use 0. 0 means internal command. And the list P1 and 8. This parameter is the torque we set. You can see now the torque is 40. 40 means 4% of our rated torque. P1, these two. This 2 is the forward speed limit and the reverse speed limit. You can see the limit is 1,800. This is the forward and the reverse speed limit. And here we can check the curve. For the torque here I set it as 10 times. So we can see it now. Maybe 100 is too big. 20 times. It's okay, and now I will change the torque. Change the torque through the servo panel. Now I change the torque to about 6%. 6%, and you can see the speed is bigger. And now the motor didn't continue to speed up because for now the torque of our motor is already same with the friction, same with the friction of our motor axis. I change the torque by changing this parameter. You can read again. Now it is 60 because I just now changed this value by the servo panel directly. So you didn't see the process because I want to show this curve, show this waveform always. And now I will change the torque to 8%. And now you can see the speed is achieve the speed limits is 1,800. 1,800. If I didn't set these speed limits, the speed will continue to speed up and speed up. And now raise the torque again. You can see the torque is 8% now. Here, check again. Now I will set the torque, reduce the torque to 3%. You can see here. You can see from these points, when the torque of motor is changed from 8 to 3, we can see the speed of our motor is slowed down. And then keep in this value. Because why will this happen? Because as the speed up, the torque we need is bigger. I mean the friction will be a little bigger. So that's why this happens. And now I will set this torque as 6%. And here, change the curve. And now I use my hand. I use my hand to hold the motor axis. You can see the speed is still now because the motor have no enough torque to push my hand, so it stopped. And when I remove my hand, you can see the speed will begin to speed up and keep at this value. And when I catch the motor axis again, you can see the speed will change to 0 now because the motor is already be kept by me. Okay, you can see the speed is changing, but the output torque of our motor is always same. Okay. Okay, and this is our today's contents about torque control of VD2 series. And do you have any questions about torque control? If you have any questions, you can ask me now. Okay, and for talk mode, usually uh, in talk mode is just like speed mode. These two mode is easy, I think. It's more easy compared with position mode. And you can keep this link. And maybe you can you will need it when you calculate some talk of the loads in the future if there are some application. And also if you don't know how to calculate the talk of the loads, you can contact our technical to help you. And this is our today's content. I will send the training video and homework in our group later, and you can check it. Okay. And thanks for your time. Our today's training is finished. See you next week. Have a good weekend. Goodbye.